Our next part, hemostasis. Trying to say a couple things at the same time. Hemostasis, stop bleeding. So remember, hemo deals with blood. Hemostasis is how our body stops bleeding so that we do not bleed to death. Whenever a vessel is injured, there are basically three things that are going to occur. Blood vessel spasm, part 1, platelet plug formation, part 2, and then blood coagulation, which is basically the clotting of blood. So if a blood vessel gets cut, the muscle in the wall of the blood vessel is going to go through a short vasospasm. So a spasm of the vessel. So a very quick blood vessel spasm. It's not going to last very long, typically a few minutes. If it does last for a long time, so we're looking at larger cuts, larger injuries. If it lasts for 30 minutes, then it's going to start the next 2 steps. So the second step, like we said, is going to be platelet plug and then on to clotting. So at this time, those little fragments, your platelets, are going to release serotonin, which is a hormone. And serotonin's job is to constrict, to make the vessel smaller. And obviously, if my vessel is losing blood, I do not want a great big opening for all my blood to go through. If the serotonin constricts it and makes it smaller, I am going to lose less blood. So basically, that's why that function happens. Then, second step, after my vessel has shrunk or constricted, platelets are going to show up and they're going to start to stick to the exposed edges of the damaged blood vessels. And basically they form a plug or a net that's going to kind of protect and stop a lot of blood from flowing through it. So a platelet plug is very effective on a small blood vessel. You know, if you cut your carotid artery, large blood vessel, a platelet plug is not going to be very effective. So that is step 2. Here you can kind of see the picture. So I have the break in the blood vessel. This is assuming that it's already constricted. So in reality, if I could make diagrams like this, I'd have one blood vessel being a bit wider, and then I'd show one that has been constricted. It's a little bit smaller. And then what happens is all these platelets are going to start to show up, and they stick very easily to this broken part of the blood vessel. So notice they start sticking on the outside, and then from the outside they work their way in and basically form a net, a bridge, almost like a clot that stops the blood from going through. And that at the bottom then is the platelet plug. It's a plug made up of many different platelets. The most effective, big vessels, small vessels, all vessels, the most effective part is blood coagulation, which is basically the scientific word for clotting. So blood coagulation, very complex, and it uses a lot of clotting factors. There are tons of clotting factors. I will not expect you to memorize them or anything like that, but there are lots of factors that promote clotting. Damaged tissues release a chemical called tissue thromboplastin, and that's going to basically be the first step. So it activates the first in a series that lead to prothrombin. And prothrombin is what converts prothrombin in the plasma into thrombin. And that is then going to convert fibrinogen into fibrin. So think fibers, and that fibrin is going to be necessary for clotting. So it's a step-by-step process. This converts this, that converts that. And here's just a microscopic picture of blood, and that fibrin, that's part of why it looks like little fibers. It's going to hold those blood cells together. So the major event is this fibrinogen turning into fibrin. And that was the picture that we just looked at. So that fibrin causes the blood cells to catch, or it holds them together. And then serum is plasma minus the clotting factors. So if you've ever had a cut and you get a scab and that white clear liquid comes out of it, that would be the serum. So serum is plasma minus the clotting factors. It's going to be clear. The amount of prothrombin activator formed depends on the amount of tissue damage. So huge injury, large amounts of prothrombin. Small injury, not so much. Once a blood clot forms, it promotes positive feedback. Remember, almost everything in the body is negative feedback. My salt gets low, I produce more. My temperature gets cold, I do something to produce heat. In a blood clot, I'm going to have positive feedback. So instead of tearing apart the clot, it is going to promote for more clotting. So once that clot forms, it's going to promote more clotting so that I can stop up that injury. Another one, plasminogen, is converted into plasmin after the clot has formed at a later time, and it's going to get rid of that clot then after it has stopped the bleeding. So plasmin eats up, digests, gets rid of the fibrin. Fibroblasts start to repair things, put your connective tissue back together. And sometimes, depending again on the size of the injury, this can take a long time. Those of you that have had a large cut, that scab, that fixing takes a long time to completely heal. Usually our clots, our coagulation is there for a good thing. It's stopping something. However, there are abnormal clots, and I'm sure you've heard of, oh, this person has a blood clot in their lung. That's a fairly common, oh, they had a blood clot in their lung. So a clot that forms in a blood vessel is a thrombus. Once it dislodges and goes to an organ, it's an embolus. So if you know someone that's had like blood clots in their lungs, those would be embolus. If they have a blood clot that is simply in their blood vessel, that is a thrombus. So they are different and they're abnormal. They're not there because your body needs it. Those are very common after stressful situations, like after childbirth, they'll watch you fairly closely, or a surgery, they'll watch for abnormal blood clots so that they do not form. Here's just the table, good review, kind of shows you the steps that things go through. And we'll stop there for right now.